All right, hi everybody. Here's another video that we're going to use just to illustrate another example of factoring using a difference of squares method. So I see I've got two terms here with a subtraction in between, so I can definitely apply the difference of squares factoring to this. Uh, Sometimes I have to kind of force it to work, but sometimes it works out quite nicely. Now here, when I take a look at this, I see my two terms, I see my difference, but I notice that 12x to the fourth is not a perfect square, neither is 75. The x to the fourth isn't the problem. It's the coefficients, the 12 here. But when I get into a situation like that, one of the first things I want to do here is recognize that, okay, it is possible there might be a common factor there that's kind of clouding the issue here. And there is, in fact. There's a common factor of 3. If you factor that out, I get 4x to the fourth minus 25. And now that is a nice difference of squares. Okay, so the square root of 4x to the fourth is going to be 2x squared. I'll put my subtraction there, my addition there, and the square root of 25 is 5. Good. Now, normally what I would do is I would take a good look at this, and I would look at that term with the subtraction there, that factor with the subtraction, and I'd ask myself, okay, is that also a difference of squares? I mean, I had x to the fourth, and I brought that down to x squared. Is this another difference of squares? And the answer is no. Well, I shouldn't say it. Yes, it is, but only if I force it. So this is likely where your teacher wants you to stop here. I do, however, want to point out that you could go further if you needed to. And there are situations where actually it is useful to go a little bit further, but they're pretty rare. So 2x squared minus 5. Could I force that to be a difference of squares? Yes. I can force it by making the square root of the first term would be square root of 2 multiplied by x. And if you just take a look at that term there, you'll recognize what I'm doing there. Now notice that the x is not under the square root. Then I'll put minus an addition over here. And then 5, I have to take the square root of that too, so it becomes the square root of 5 there. And so I could write it out like that. Does that work? Yes, it does. But I'm kind of forcing it to become a difference of squares. And usually I'm only going to do that when I can see that it's going to help me simplify something else in a problem. In most cases, like we pointed out, this is the step that we want to stop at.